Welcome to episode number 146 of CXO Talk. I'm Michael Krigsman, and today I'm so excited because I'm speaking with Stephen Hoover, who is the CEO of the Xerox Palo Alto Research Center. Xerox PARC is one of the most venerable research organizations in the world. And I'll let Stephen describe all the incredible day that were originally developed at PARC. And so, Stephen, welcome to CXO Talk.
Thank you, Michael. It's good to be here.
So, Stephen, just to begin, very briefly, tell us about your background. So you're the CEO of Xerox PARC, and how did you get there? But really briefly.
Sure. I have my PhD from Carnegie Mellon, and I've always been very interested in technology, from a technology side at kind of the confluence of the physical world, computation. And so my research area, technical research background, is in applications of artificial intelligence to design tools, advanced methods of computer-aided engineering, and then robotics and mechatronics. And when I finished my PhD, I joined Xerox actually quite a while ago, 21 years ago, and have been in a variety of innovation positions since then. Moving from the research side into product development and delivery, and back into the research side and some technology strategy roles. So it's been a really interesting opportunity to kind of live across the whole spectrum of innovation, from crazy early ideas that you don't know to work to supporting 10 million customers with a new product release.
So you're a scientist who's now managing scientists and researchers, and I'm assuming some engineers, people with different kinds of backgrounds. Right. Tell us about Xerox PARC.
Great. So it's a really interesting place, and we have as you said earlier, I think a storied history of founded in 1970 by Xerox, specifically chartered to create the Office of the Future. And we did some of the foundational work in personal computing, the creation of Ethernet, which we actually spun out of here in 3Com, to the creation of the graphical user interface and the integration of the mouse into that, to what you see is what you get editing, to the invention of laser printing and the commercialization of that, and have continued in that vein. Developing innovations for Xerox's business today, which is much broader than a printing business, but is in fact half of Xerox is in the services business. We do transportation services for cities and other local governments, ranging from things like the EasyPass toll system. Many of your users probably use EasyPass, to fare collection systems. We do work for healthcare companies in analytics and information management. We do customer care. We answer $2.5 million customer interactions every day, Xerox does. And so at PARC, we are set up as a wholly owned subsidiary to support Xerox by developing early stage technologies and innovation to drive into their business. But what's interesting is we're set up as a subsidiary also because we're a P&L in the sense of we're in the open innovation business. So we do that not only for Xerox, but for other clients and customers in this world. We stepped into this model in the early 2000s, focused on open innovation as a business practice, actually before Henry Chesbrough coined the term open innovation in 2003. And it's been it makes this a really interesting place, as well as the business model and that focus on not only some long-term innovation and research, but also how do I drive current business results, from that, putting those two together, and then, as I said, doing it in this open innovation business model.
So So what is the relationship that you have with Xerox? It's really interesting that you're an R&D organization that also has a P&L. And so as you talk
Right.
about the relationship with Xerox, what does that P&L responsibility imply for you?
Right. Well, so we have then two fundamental, roles for the company. One, again, is to do early stage innovation and research for Xerox itself. And so we have a relationship that then, looks like any, what would be the, not any, but the innovation organizations for large companies that do that well, which means you are, closely working with the business units on their strategy. You're developing technologies and new offerings that extend their current business and take them into, radically new places. You're working with corporate strategy, again, to ensure that you are both being influenced by the strategy, but also influencing the strategy about where it needs to go, what technology will enable, and what new business opportunities come out of that. And then in addition, we have this role in open innovation where we, again, many of the early stage technologies that we work on are very relevant to people outside of Xerox. So how do we go and find those customers and clients to help them in their business? And then even find relationships where we may do an early stage innovation work that we start to work with an external company, and then we bring that company in as a partner for Xerox to extend its offerings. So this open innovation is a really interesting model.
So is the reason for having a P&L so that you can self-fund the organization, or are there other reasons beyond that?
It's certain one of the reasons is absolutely to be able to look at a broader reach of one of the roles of if you are a good innovation organization for a parent company, then what you are doing is developing innovation to support their current businesses, but also innovating in new businesses that they're not in today, to give them options to expand beyond their current markets. Now, it may turn out that some of those things aren't the right things for the parent company to take up for a variety of reasons. And then what do you do with those? They may be great ideas, but the parent company isn't the right place to do that. Or it may not be clear in an early stage technology or opportunity what the real opportunity is. So how do you go explore that? Well, you go explore it by creating those opportunities yourself as an innovation center and finding other companies to do it. So it isn't, one aspect is, yes, it allows us to have a broader set of innovation exploration areas, but doing it in this way, it forces you to do it kind of in the crucible, of a market still, even if it isn't clear that the parent company is the right company to take that up or in what form. And so it kind of keeps you honest in some sense in that regard, because you're forced to go out and compete, in that way and survive. So yeah, part of it is the funding to be in broader areas, but part of it is, it's a great crucible to test out new ideas. And, my experience, long history in innovation, there are three major reasons why significant innovations fail. One of them is the technology isn't right. It's not ready. It doesn't work. But another is that you've understood the market wrong. You're not actually solving the problem, in a way that customers will adopt. And the third is that you don't have the right business model. That while you're creating value in the world for those customers, you don't, you're not able to kind of appropriate value across the ecosystem to the right people in the right ways, so that the whole value chain makes money, right? In the end, businesses are going to need to make money to deliver a product successfully to a customer over the long term. And so if you're not exploring those other two aspects, the market and the business model, then I would argue you're actually not doing a good job of innovation. And so this gives us a much broader way to explore those, areas.
To force you, as you said, into the crucible of market relevance. Steve, we've lost your video, and I'm not.
Okay.
So make sure it's plugged in. If not, we keep going because we have your audio. But it'd be nice to see you as well as we saw you earlier.
Google Hangouts says I'm on, and I see myself. So sorry, not sure what the problem is.
Okay. Well, there's nothing to be done about that.
Okay.
So tell us about research at Xerox, the basic research versus applied or product research.
Right. So one of the, if your listeners are interested and kind of want to understand this business of applied research versus basic research and how to kind of think about that in a model, I can refer them to an interesting book and a concept called the book is titled Pasteur's Quadrant, and it's trying to capture in a 2x2, right? If you're, in MBA school, we learned to, describe the world in a series of 2x2 matrices, right? And this 2x2 matrices basically, in this case, is articulating that one axis is about how, is it about knowledge for knowledge's sake, or is it about solving a problem? And the other axis is about how basically the kind of time horizon over which you're operating. And Pasteur's quadrant is this upper right quadrant where the idea is it's not so much about knowledge for knowledge's sake, but it is about generating new knowledge and new science, because there's a focus area in which you need new knowledge and new science to understand the world, and then to create things in the world which deliver the results that you need. And that's the idea of Louis Pasteur. He was very focused on not just new knowledge, but okay, we have, how do microorganisms work, right? What is going on in this space, and knew that knowledge was needed to then lead to things like antibiotics and antiseptic, et cetera. And so we live in that quadrant, and kind of then the one below it, which is, okay, with that new knowledge, now how do I actually turn that into a product or or an offering? So I described that left axis wrong. It's about that. Is it about a product or offering, or about knowledge, and is it about knowledge for knowledge's sake, or is it about application? And so we live more on the right hand side of that, and balance between the upper right and the and the lower right. So we do care about understanding and knowledge generation, but generally it's in a focused area where we believe that we can both contribute to the quality of the knowledge and convert over time that knowledge into an innovation, right? And that's one of the distinctions between an innovation and an invention. Is an innovation is an invention that's solving a problem, right? That people care about, and in the end we are about innovation, right? But to do that, we do good science in those focused areas, and that's the balancing act that I think you've got to walk. And a lot of the more pure basic science, understanding the world, right? String theory, those types of things, that is more in an academic environment.
And what are the research areas or the innovation areas that PARC is focused on right now?
Excellent. Yeah. So we've got 5 core areas. One of them is a lot of people are focused on big data analytics, and we certainly are as well, because right, the amount of data in the world and the sense making that you can make out of it is really it is absolutely one of the forefronts. One of the things that we try to do is bring a unique perspective to that, which actually ties back to our history. And so I call it human-centered big data. And what I mean there, and I'm going to start with an analogy, right? So one of the things, as we described earlier, that PARC did it, in our foundational days, is we looked at computing technology and we made it so that people, average people, can use it, the personal workstation, that you don't need to be a computer programmer, an expert. And we were able to do that because we understood how work got done in an office, right? And this is, again, one of the values that Xerox brings to, to the market today. Xerox talks about work can work better, very focused on the job that a person is doing. And our role is then to understand the jobs that people are doing and how technology can help make them get that job done. And in a way, again, that is easy for the person to adapt. So for example, one of the things that we're doing today is in the support of Xerox. Xerox, as I articulated earlier, has a significant business in customer care, right? So 2.5 million customer interactions daily. Well, how can we learn over all of those interactions which is a more likely problem to solve, a more likely answer to a problem a customer has? And how can we do that in a way, you've got today capabilities where computers, automated chatbots, right? You're chatting over the computer, and on the other end is not a person initially, but a computer agent. Well, it turns out that computer agents are pretty capable, but there's a place where they run out of knowledge, right? And what you don't want to do is tick off the customer on the other end, because you've got this kind of what starts to become apparent is this stupid agent asking them stupid questions and not really resolving their problem. So we're developing technologies to actually have dialogues and monitor that dialogue. Is the person getting frustrated? Does the conversation seem to be regressing? And if not, how do you seamlessly hand that call over to a live agent in a way that nobody even knows and can detect, but all of a sudden there's a person on the other end answering the question because the computational agent has run out of its ability to solve the problem. And so this idea of, again, human-centered big data, and here the human is, both sides of that equation. The end customer, right? So really understanding their state of mind, what are they doing? And then the call center agent, and how are you helping them, take over that call? And then, as I said, actually using that as a learning opportunity. Now we watch what the customer care agent, the human, does to solve the problem. We take that data and through machine learning, make our diagnostic algorithms better for the next time. And so thinking of this, I personally think there's a kind of a really big, I think there is a big idea in here that is, there's a lot of focus on pure automation, and that's good and it will happen. But as computers become more and more capable, you're reaching this point where we're going to have human computer teams solving problems. And how do you interact together to come up with a better answer? And there's a lot of science in that. There's a lot of technology in that. I can give your listeners an example. Is it used to be that humans were the best at chess in the world. And then artificial intelligence technologies came along and computers beat the best humans in the world. Big surprise, a little over a decade ago to many people, to many chess players. Well, who are the best chess players today? Human computer teams. Literally, you take a person and a computer and they work together, because computers are really good at kind of deep, fast search, evaluating all of these alternatives, but they're not the best at kind of what's the high level strategy. So human may thinking about 3 or 4 strategies, the computer investigates those 3 or 4 strategies, tells the human likely outcomes, the human therefore picks the next strategy, and they play back and forth in the cycle. And that's what is the best chess player today. And we're going to see work happen more and more in that way. And so we have a significant investment in this whole area of machine learning, empathetic computing, understanding, again, what's people's intents and behaviors and how do I help them.
So a core foundation of what you're doing is this notion of simplicity and making the problems applicable so that people in ordinary offices can make use of these technologies.
Exactly. Work can work better, and it's about so it's interesting. You talked earlier and about there definitely at the park we have a large number of scientists and engineers in the physical sciences, and in electrical engineering, mechanical engineering, but we also have social scientists, cognitive psychologists, people who are experts at conversational analysis, ethnographers who go out and understand and observe. Again, as people are doing a job, what is the real job they're doing, and what are the things that are hard and easy about it, and what would help them best? And there's a whole, so recognizing, again, you got it that right, that this is about how do we do this simply and in ways that stick with people, that actually they can use, requires that kind of deep understanding there, as well as, design thinking and those types of things. But it's more than that. There's an actual science into that. And then we do work in the areas, again, of modeling cognitive processes of people, right? How do people think? We have some very interesting work in those areas, particularly around human behavior. We all have this experience. One of the hardest things to do is to change yourself, right? Be it I want to eat less, I want to exercise more, whatever that is. There's an actual science of how change happens, and people. A lot of people are saying, we're going to build apps to, monitor your food use and kind of be the nanny on your shoulder telling you what to do. That's not enough. You actually have to, again, understand how people do change behaviors, and then build those artificial intelligent agents and chatbots to provide the suggestions and advice to people in a way that actually sticks. And so, for example, we've gone out, and it turns out one of the best ways for people to make changes in their lifestyle is a coach. And we've gone out and done ethnographic studies of how coaching works. Why does that work? And then how could you provide the same, and coaches are very sensitive and they're very dynamic, right? Watching how you're behaving, how do you respond, and then giving you the right nudge, and are you a person, some people respond more to, hey, why don't you try harder? And some people respond more to, hey, that was a great job, right? And a good coach knows which you are and picks that up and kind of tunes their message and styling to you. So again, how do we have computational agents who determine your personality profile and address you in that way? And there's a lot of science and research we're doing in those kinds of areas.
I spoke yesterday with a woman named Julia Hu, who is CEO of a company called Lark Technologies, which is actually working in precisely this area you were describing of coaching. So they take sensor data from phones, and then they take human experts, and they deliver it through an app, deliver the coaching through an app. So it sounds like this is a similar kind of area.
Yes, and a very similar area. And then how do you engage, people's social network, right, into this in a fruitful way? And again, there's some science there about what makes good teams, right? How to build a social circle to help in this case that is, again, the right mix of people and the right kinds of things. And yes, how do you create AI agents who can perform some of the coaching capabilities? That's dead right. And it's interesting, right? We're doing this for a variety of reasons. I mean, it's actually very relevant, as I said, for Xerox, as well as some of our customers outside Xerox. We do a lot of work today with healthcare companies and helping them kind of manage their information processes, and more information is about their patients. What are they doing and how are they behaving? And so we see moving from not only kind of managing the digital flow of information inside the enterprise, but helping then health enterprise organizations serve their clients more directly. I mean, as everybody becomes more and more connected, I think there are fewer and fewer B2B companies, and everybody in some sense becomes a B2B to C connected customer, because again, Xerox is more of traditionally a B2B business, but as our business customers are connected to their customers in real time, which we all are when we're in a connected world, we all become a B2B to C company. And so that's part of the progression that we're on.
So as you're dealing with these future of work issues, you're talking about technologies, but at the same time, there's just as much a cultural and human and social set of dimensions. And so you must be addressing those as well.
Yes, and there are kind of two sides to that, and let me try. And one is, inside our own innovation environment, right? So one of the things that we really value at Park is we think a lot of innovation comes from multidisciplinary work, which kind of makes sense, right? Because, okay, there's a well understood area, a field, a silo, a technology, and you make progress in that field. And then there's another one. And if you can connect the two in interesting ways, then, that's a white space. It's a new opportunity. And so I've talked about, there's a lot of focus on big data and on what computers can do. And we're saying, well, but wait, it's also about how people learn, how they think, and, marrying those two together. And so one of the cultural things we try to do is to leave space for people to explore those white spaces. Because I think that's a key piece of innovation. The other piece is, a lot of ideas, when you start out, it's not clear where they're going or that they make sense. But some of them will. And if you try to kind of narrow down and control those too early, before people have had the time to experiment and figure that out, then you're going to miss a lot of innovation opportunities. On the other hand, if you just keep pursuing a bad idea, well, you're wasting everybody's time and money. And so there's this real balancing act about how do you give people enough freedom to kind of explore something at the beginning that it's not clear that it makes sense, but they've got to have the kind of ability to go and figure that out. And you've got to let people be, you got smart people who can think out of the box. You got to let them be a little crazy every now and then. And if you try to turn this too much into a tops down process, you're going to end up in a place that's not very innovative. So there's this real balancing act between how do you set kind of some large strategic goals, and then how do you give people the white space to innovate, but then how do you find the good ideas from the bad ones and kind of invest more in those? And so there's a whole art to that.
So how do you herd the genius set of cats inside that crucible of the market reality to produce something that's absolutely great?
Well, and the other, I'll push on you a little bit, is, yeah, that's a piece of it, but how do you let them herd you? It isn't one way. I mean, I don't know where all the right places to go are, right? I've really gotten excited. I mean, you heard me earlier about this kind of idea of human computer teams, because some people here, they started to, and it does resonate with some things inside of me, as I said, that I see a strong value in this idea of connecting humans and technology and solving their problems together. And again, that's just a core piece of who Park is, but framing it as this idea of human computer teams, right? That's not something that I came up with. That's the cats who herded me, right? And they start to talk about that when I say, that's an interesting metaphor, right? I mean, some level it's a metaphor, right? But metaphors are powerful because they give you different ways to think about things. And so when you start to think about that way, that's a different way. So it's not only how do you herd those cats, but how do you get herded, if in a way. And that's a really important piece. And if you want people who are innovative, you've got to be open to that. I mean, or they're going to go, somewhere else where people will stop and think differently, right? If I can't think differently after some of the people who are working here have new ideas, then you better fire me, because I'm not going to get the job done. So it's a two-way street.
So being adaptable, so you yourself being adaptable in terms of what you're doing, and I'm assuming also in terms of the strategy of the organization to some extent.
Strategy of the organization. What are the technical directions? As I said, is this kind of whole framing around human computer teams is it's a relatively new framing, and I think again one that it's differentiated and valuable, right? Which is what we ought to be doing.
What about some other areas, such as the Internet of Things or automation and robotics? I know you're doing work in areas such as that. So talk about that a little bit.
Yeah. So the couple of different ways into that. So certainly the Internet of Things we see as the analogy that I make for people is a really important trend, and for people who haven't kind of thought about it deeply but have heard about it, I think this is a useful analogy. If you think about it, you know, one of the things that Google and search has done for us is it has infinitely expanded the capacity of the human memory, right? I don't have to memorize all the facts in the world. I can go out and look them up and find it. If I want to learn about reinforcement learning, you know, I go and Google it and I find the Wikipedia article and I learn about it. So it's expanded my brain, my memory to be, you know, of nearly infinite capacity, right? That I can quickly and easily, right, find that new information and integrate it when it's relevant to me on a problem. The analogy I want to make for you and your listeners about the Internet of Things is it's about Googling reality. It's about, right now, my body, right? My body is the sensor, right? I see things, I hear things, I sense the world around me. Well, why does that have to be geosynchronously, and it has to be, why does it have to be synchronous in time and space with where I'm at, right? Which is what my senses normally are, right? They're, I sense something at the time it occurs and it has to be near my body. Well, the Internet of Things says, no, it doesn't. I want to understand the state of pollution in Beijing. I go and find it on the internet, right? So this idea of kind of expanding your body, right? And now, take that idea, and that's for an individual, now for an organization, right? I can instrument and understand what customers are doing with my products across the world. Now, I can understand, are those machines, are those devices starting to fail? I can understand the environment that they're in and adapt their behavior to be responsive to the local environment, right? GE and their jet engines, when a plane's running into a headwind, run the jet engine differently because I know I'm in that situation. And so this idea of the Internet of Things, and then you couple it with the data analytics and the machine learning, right? So I can make sense of all of that data, right? Again, to get a job done. What's the problem you're trying to resolve there? And in our case, we for Xerox, we put up, again, transportation systems, cameras, where our car is going. We as I talked about, E-ZPass. That's an Internet of Things. You put a little transponder in your car. It senses it goes by. It knows it's you. It charges your credit card. But now, why do I even have to put the transponder in the car? I'm going to have a camera up there take a picture of your license plate because computers can see. And now I can see how many cars go by, and I can help cities understand how to manage traffic better. I can have there's cameras all across cities for a whole bunch of reasons now. I can be looking at parking and helping people find where's the open parking space. Connected cars drive by. How many cars today, right? I think it's a regulation either today or next year that all cars will have a backup camera. Well, you're driving down the road, your camera's seeing where there's empty parking spots. How do I get that information and direct people to the open parking spot to optimize, again, the capabilities for people to get the job done they're doing? And so in our view, that's the power of kind of the Internet of Things, and you're going to capture that power. So then from a technology viewpoint, where are we working? One is those analytics to kind of optimize outcomes and behaviors. Another, we have a significant investment. I talked about our foundational work with the creation of Ethernet. We have a totally radically new networking technology called content-centric networking that really deals with two things: the explosion of information that is occurring and is just going to radically increase with the Internet of Things. Because now if I can Google reality, imagine all that data. And the reality is the current Internet protocols aren't designed to handle that kind of quantity of data. And the other piece is, we all know, the security. It's not built into the network. It's an add-on. And so content-centric networking is a technology that builds security inherently into the network, and therefore is much more secure. And then the third area for us is the the Internet of Things, I talked about a lot of it is it's sensing the world. How do I do low cost, highly distributed sensing? If I'm going to put the things on the internet, if it takes $100 to put a smart computer on a bottle of vaccine to measure its temperature during its shipping, well, I won't do that. But we're working on technologies in areas like printed electronics. How do I make very low cost electronics that are smart enough? Silicon, it's got cheaper and cheaper to put more and more transistors. My iPhone is the power of a Cray supercomputer from 1996, and I can buy it for $200 with my 24-month plan. But if I want to put a temperature sensor on a bottle of vaccine, like I said, for 50 cents, the reality is I don't need a whole lot of intelligence. And it's gotten cheaper with silicon to cram more and more intelligence. But what I want is a whole nother price point down at that dollar smart label sensor that I can put out and sense those things. So we have a whole focus area in printed electronics because we think that's the internet of everyday things. And we have a set of partners in that area. And we are also working with Xerox, to take some of those initial technologies to market.
How does this actually work? Do you have projects with commercial companies, or what are the mechanics of that?
We have, so sort of our open innovation business. So the mechanics of this are, yes, we have three classes of, four classes of kind of open innovation models. I mean, one is a pure kind of collaboration, right? We're working in an area, we'll go out and find a university or a commercial company who's got capabilities in this area, and we kind of form an agreement to team and kind of, I'll solve this part of the problem, you solve that part of the problem, we'll share and compare information. And that's kind of the classic way that a lot of open innovation happens, and by and large at most companies it means with universities. The different thing that we do is we also go out and we do a fair amount of early stage, high risk research under government funding, because it turns out that the government is willing to fund and has a process to fund a fair amount of potentially high value, but high risk, longer term research and technology development. So we go get research contracts with DARPA, if you're familiar with them, the kind of far out, the crazy wing of the Defense Department research, right? We don't do any classified work, but a lot of what they do isn't classified because they're trying to, again, just uncover new areas. We do work with the National Institutes of Health. We do work with the Department of Energy in those areas. And then we also work with commercial clients where we are helping them innovate in new spaces, and that'll take two kind of forms. Sometimes it's a problem that they have, and we co-ideate with them. How could you solve that problem? We'll generate ideas, generate a project out of that. We have a whole process for this. Again, kind of our history in innovation. There's a way to approach that initial stage of ideation, and we work with them and develop that, and then if we find a good idea, they'll partner with us, fund us to do the forward-looking research and innovation in those areas. And sometimes it's, again, innovations that we've already developed, be it on government funding or other sources, where we're taking, we're partnering with them to take that to market. I can give some examples if that would be useful for you.
Well, we've only got about 5 minutes left. And okay. I wish we had another hour, but maybe tell us about automation and robotics. What are you doing with respect to that?
Right. So a lot of our focus comes in two ways, and one is ties very much to, as I articulated today, kind of half of Xerox's business is in a document and information intensive business processes. And so there's what we call robotic process automation, which basically is looking at current workflows and work streams that are not automated, and how do you automate them in a digital world, right? So this isn't physical world automation, this is digital automation. It takes the characteristic of the analytics and things that I talked about, and again, automating customer problem resolution. And so there's a whole focus in that area. In terms of the automation in the physical world, we're focused on, and this is one of those areas where we're kind of in advance of where Xerox's current business is, but I think there's some interesting long-term opportunities for it, is what we call systems of systems. So you're going to see that. So here we're doing some interesting work with the Defense Department about, you know, what a past example that I can talk about we've done is satellite swarms, which is basically, the idea is, right now we build one big satellite and send it up in space. And if that satellite, it's really expensive, and if it fails, you're done. What if instead I could build a series of small satellites that were all individually redeployable but controllable in some coordinated way? So I can, you know, it's a swarm of 50 satellites, small and cheap. Well, if one dies, that's okay. When I want a lot of imagery on a certain place, I'll aim 50 at the same place. When I don't, I distribute them. And there's a whole challenge of, basically, if you think about it, you've got this complex system and you're trying to redesign it constantly during its use, because you're trying to have it do different things as pieces fail and don't fail, multitask, again, to look at different problems, to sense different things. And so there's a whole science around kind of AI planning and thinking of how do you manage that system of systems. The other piece of it is back to my human and computer teaming. In the end, those systems are being tasked by a human. How does a human interact with that level of complexity and manage it and help the system, which has local autonomy, understand what the human, the task the human is trying to perform, and coordinate and adapt together? And so we're working in that space. And I think this is, you know, think about it as, you know, the Google autonomous car. Well, what do you do when you've got 1,000 autonomous cars on a road? And how do they behave together? And how do they behave with the humans who interact them? So we're at that system level of the problem, and we think that's where the kind of the next wave of complexity, as automation occurs, it's going to be systems of systems interacting, and the science and, again, the interactions with people are, we think, really interesting problem spaces.
So a core part of your activities, it sounds like, are this notion of where the person and the computer come together, and how does the person accomplish something of value using the computer and manage and have the computer be structured and the user experience be structured so that the human can manage that complexity.
Exactly. And there's a whole set of science, again, around that some people say, oh, that's design. No, it's more than design, right? You know, it's, again, how do I understand, how does a computer build a model of the world that's a shared model with the human? Because, again, there's assumptions that you and I have a conversation, there's a lot of implicit assumptions that we share, and those evolve over the conversation. How do I do that? Again, understanding, are you a pessimist or an optimist? Are you a realist? And how do you take information in better? And what is the best way to split the task that, again, leverages the strengths of computers and people? As computers become more capable, that becomes even more important and harder. And how do you leverage that? So there's a whole host of scientific and technical challenges in there that we're investigating.
Wow, it's a fascinating conversation. Steve, as we leave, unfortunately our time is just about up. What advice do you have for organizations who want to innovate? Maybe they're stuck with their traditional processes and having resistance and pushing back. Folks in those organizations, how can they do a better job of pushing innovation?
The biggest, so I'll tell you, the two biggest things that I see that people struggle with are, one is this idea of risk. Exploring new areas and ideas is inherently risky, and so much of our business process where you're about delivery of something is about risk avoidance. And in innovation, you need to do the exact opposite. You need to embrace risk. Not because risk is good, but because the reward that comes with solving that problem is valuable. And then, as I said, it's not about risk avoidance. I said earlier, there's three kinds of risk: technical risk, market risk, business model risk. Wherever the biggest risk is, how do you create an experiment to uncover, is that risk? Risk means I can't predict the future. To predict what is going to happen, or to design the system to, so that risk doesn't come true. So there's this weird mentality shift of embracing risk and then agile learning processes around that risk. The other piece I would say is the hardest thing for existing businesses to do is to innovate in a way that challenges your current business model. New technologies can radically change business models. And if you're not open to that, you're going to get caught behind the eight ball. So how in your organization are you leaving space? And it can be very painful at first. I mean, if you're used to selling hardware and software and cloud computing comes along, you're going to think you're going to make less money because people are going to buy fewer computers, and you don't get as much money off of every unit sale in the cloud, and they can only buy, they can buy it by the drink. They don't have to buy a peak capacity. They buy the dynamic capacity. So yeah, you'll make less money on each transaction, but the consumers in the end will consume more of it. And that's the opportunity you're going to get. But it's really hard for existing businesses to see that. So set up space where you are innovating, exploring innovation in ways that hurt your own business. If you don't do that and technology changes your business, you will end up a victim, and you don't want to be that.
Well, it sounds like what you're describing is the philosophy that you said earlier, that you aim to yourself, that you have to let the cats herd you as well, which means be open to change and be adaptable and flexible.
Yes, very good. Yes.
Well, Stephen Hoover, CEO of Xerox Palo Alto Research Center, known as Xerox PARC. Thank you so much for taking the time. This conversation has gone by just in a flash, and it's been fascinating. Thank you so much.
Thank you. Take care.
And to everybody who has been watching, we really appreciate it. And come back next week, where we will be talking with the CIO, the Chief Information Officer for the City of Palo Alto. Thanks so much, everybody. Have a great week. Bye-bye.